if E denotes expectation, the variance of a random variable x is given by this. Is a very straightforward question. We know that expected value of x minus mu whole square is what you call as variance, and mu is nothing but the expected value of the random variable. It is the mean of the random variable. So mu is expected value of random variable. I just square it, so that I'll be getting expected value of, I am going to square this, x square minus 2x mu plus mu square. Now I take the expectation inside the bracket, so that I can write expected value of x square minus 2 mu is a constant, 2 mu into expected value of x, right, plus expected value of mu square. But mu is a constant, so expected value of mu square is mu square itself. So finally what I can write is, this expected value is also mu, because expectation of x is mu. So this is mu square, 2 mu square, plus this becomes mu square. So minus 2 mu square plus mu square is nothing but minus mu square, which is nothing but minus expected square of expectation of x. So the final answer will be expectation of x square minus squared value of, right, expected value of x. So the answer will be e of x square minus e square of x. The discrete random variable x takes values from 1 to 5 with probabilities as shown in the table. Student calculates the mean of x as 3.5, and her teacher calculates the variance to x as 1.5. Which of the following statements is true? You have four options. Both are wrong, both are right. One is wrong, the other one is right. Like that, you have 4 options. So seeing the table itself, you can say that the mean must be 3, because this is 1, 2, 3, 4, 5. So the random variables are equally spaced, and the probability for 1 same as that of 5. So they get the same height. The next two things, 2 and 4, they take same heights, 0.2, and the center one has got a value of 0.4, which means that it is centered around this particular thing and it is symmetric. So at this point 3 is symmetric. With respect to this point, this PDFs, or rather this distribution, the probability values take a very symmetric shape, which means that 3 must be the mean value. What it means is that this is the random variable, and the random variable takes values 1, 2, 3, 4 and 5. So when you find the expected value, what you are going to find is the most expected value that k could take. That is what you mean by expectation. Seeing the graph itself, you can say that the most expected value will be 3. It is not because of this particular height, because but because of the fact that when you take expected value, you are actually going to take a weighted mean, or you are actually finding the centroid of this particular thing. So it is 3, but if you cannot find it using the graph or seeing the table, there is no problem in finding the expected value in the traditional manner. So what you do is, you find the expected value of k by taking the sum of product of k with pk, right? So I am going to multiply these two things and take the sum. So when I multiply these two things, I'll be getting 0.1 here, 2 into 0.2 is 0.4, 3 into this is 1.2, this is 0.8 and 0.5. So when I add these things, I'll be getting, this is 0.5 plus 0.5 is 1, 1 plus 2 is 3. So I get the value of 3. So the student is wrong. Now we need to find whether the teacher is right. I know that variance is expected value of square of x minus mean square, right? So mean already I have found, and mean is 3. I've got mean as 3, right? I've got the expected value of k as 3. Now I need to find the expected value of square of the random variable. So I have taken the squares here, 1, 4, 9, 16 and 25. I am taking the squares of squared values of k. Now again I have to multiply it with this thing. So I'll be getting 1 into 0.1 is 0.1, 4 into 0.2 is 0.8, 9 into 0.4 is 3.6, 16 this is 3.2, and 25 into this is 2.5. So When I add these things, these things I'll be getting, this is 4.5, right? 4.5 plus 2.5, I'll be getting 7, right? 7 plus 3.2 is 10.2. So my expected value of square of the random variable is 10.2, minus mean square must be 9. Mean is 3, square of that is 9, which means that my variance is 1.2. So even the teacher got the answer, teacher got a wrong answer. So the thing is that both the student and teacher are wrong. Let x be a real valued random variable with expectation of x and expectation of square of the random variable, denoting the mean value of x and x square respectively. Which relation holds, the relation which always holds true is, you have 4 options. So we know that variance is nothing but expected value of x minus mean whole square. Mean is nothing but expected value of x, the most expected value of x. Now what I can say is that x is a real value, and the most expected value of x will also be a real value, right? Because x takes values only that are real, so the most expected value will also be a real value. So these things are real, and the square of a real value will always be greater than or equal to 0. I know that. Now this is a positive number, or at least it is a non-negative number. 0 includes in that, maybe. This is a non-negative number. Now the expected value of a non-negative number will always be a non-negative number. So this is what I know. Now once I expand this, I'll be getting e of x square minus 2x mu plus mu square, which is nothing but expected value of x square. I'm taking the expectation inside, minus 2 mu is a constant into expected value of x plus expected value of mu square. Now this directly says that this is nothing but mu. So this becomes minus 2 mu square plus expected value of a constant is that constant itself, which means that this is mu square. So minus 2 mu square plus mu square. So what I get is expected value of x square minus mu square, right? This is minus 2 mu square plus mu square, which gives me minus mu square. But I know that minus mu square is nothing but minus expected square of, the squared value of expectation of x. Now this is always greater than or equal to 0, which directly implies that e of x square will always be greater than or equal to square of expectation of x. So this must be the answer. Let x be a real valued random variable which is uniformly chosen from a set of positive odd numbers less than 100. The expected value of, the expectation e of x is. So the numbers will be 1, 3, 5, right? We are selecting odd numbers, and total we have 50 such numbers, right? Total we have 50 such numbers, because this is the first number, this is the second number, this is the third number. So the relation is something like this. 2, if this is n, this is taken as n. 2 into n minus 1 is this particular number, right? 2 into 1 minus 1, 2 into 2 minus 1, 2 into 3 minus 1. So like that, I need to find the value of n here. So I know that 2n minus 1 is 99. So when I take this to the side, I get 2n is equal to 100, or rather n is 50. So I have 50 such numbers. So all these numbers are equally likely. That's why it is given that it is uniformly distributed. So if I write the probabilities here corresponding to these things, all these things will be having a probability of 1 by 50, right? So now I need to find the expected value of x, which is nothing but actually the mean of all these numbers. So expected value of x is sum of x into, this is x, this is p of x. P of x is common for all these numbers. So x into p of x, so which is 1 into 1 by 50, right? Plus 3 into 1 by 50 plus 5 into 1 by 50 like that. 1 by 50 etc. up to 99 into 1 by 50. Right. So what I'm doing is 1 plus 3 plus 5 plus etc. 99 divided by 50. So now I need to find that. Now I need to find the sum of this numerator. So this is, you can deploy any of those methods which you have already learned, or you can use your common sense. If you go for arithmetic, the sum of arithmetic sequence, I know that it will be the sum of an AP will be n by 2 into first term plus last term. So I have 50 terms. I know that I have 50 terms. So n by 2, I'll write the 50 here, into first term plus last term, which is 100. So the expected value will be 50. So my expected value will be 50. A fair coin is tossed repeatedly till both head and tail appear at least once. The average number of tosses required. So if this is the case, I know that this is the this I'll take x, the random variable x is the number of tosses. P of x is the probability. So here the length is 2. I require 2 tosses. Now the probability for this is 1 by 4. Right. Probability for one head and one tail is 1 by 4. The probability for one tail and one head is also 1 by 4. Right. So with half probability, adding these two things, with half probability, I can say that my length will be 2. With half probability, I can say that my length will be 2. Now I have remaining half probability about which I do not know. Now if I get head, now again the next toss is tail, my problem is solved. With probability 3, with the probability of 1 by 8, I can say that my length is 3. Again, if I get a head here with probability of 1 by 8, I can say that my length is 3, which means that with 1 by 4 probability, I can say that x will be 3 with 1 by 4 probability, because I can add these two things. So the length will be 3. The number of tosses required will be 3. So with 1 by 4 probability, I can say like this. So I can multiply these two things and find the expectation in the normal manner. The traditional manner, I can multiply this. Then again, when x is 4, this will be 1 by 8 or something like that. Then you go on and find out a method to solve the problem. Find the expected value. But in certain other problems, it will be very difficult for you to arrive a particular kind of series where you can find directly the sum. So there we use a recursive method to solve the problem. We will apply the same thing here. I have said that with a probability of half, I can say that this is my length. The length is 2. Now, if one head follows another head, I have lost a chance here. And again, if one tail follows a tail, I have lost a chance here. And these two things, a head, I am not considering this thing. Head and tail happens with a probability of 1 by 2. Right. These two things happen with a probability of 1 by 2. And then my problem is solved. I actually have a length of 2. Now with half probability, what I can say is that when I get a head followed by a head, this first head is wasted, because I actually require, if it is a head, I require a tail, and if it's a tail, I require a head. So when head follows a head and a tail follows a tail, the first toss is wasted, which means that from here I am starting the experiment again. So if I say that the expected value of x is a, what it means is that when head and tail comes and tail and head comes, the problem is solved. With half probability, I can say that the expected number of tosses will be 2. Whereas if head follows a head and a tail follows a tail, what I can say is that with a probability of 1 by 2, I have to repeat the experiment. Right, I have to repeat the experiment from this point. From here onwards, the expected value will be same, because the first thing is wasted. Now I have got a head. If the next thing is a tail, my experiment is solved. Whereas if the next thing is a head, again I have to start it, but it is similar to what I have done earlier itself. So this length will be a. So with half probability, I can say that my expected length will be incremented by 1. So now these two things add up to give you 1, which means that with half probability I can say that it is 2, and with half probability I can say that my length will be incremented by 1. So this is the total scenario. So if I go for the expectation with half probability, the length is 2, and with half probability my length will be a plus 1, and this will be a, right? So when I go for the solution, this is 1 plus a by 2 plus 1 by 2, say. So this is a by 2. So a by 2 is 1 plus 1 by 2, which is 1.5. So a must be 3. So my expected length will be, or expected number of tosses will be 3.